So first of all, thank you very much for joining. I know everybody has a very, very busy schedule. So it's nice to be able to get people in attendance. I am Jay Zaidi. I'm the managing partner of AlyData, and we specialize in data management, data governance, and analytics. And in this two-part series, I'm going to be talking with Damian Danowski, who's the managing director of Airlines Reporting Corporation, and we're going to talk about their data journey and some of the interesting learnings from that. And I will let Damian introduce himself in a minute. As you can see on the screen, AlyData's mission is to help our clients to transform their organizations to drive business value from data and information. And we do that through three primary service offerings. We have a Chief Data Officer Advisory Service, where we advise and help Chief Data Officers with their mission and execution of their programs. We have a Data and AI Governance service offering, and then an Insight service offering, which is all about converting data into insights. So that's a little bit about the company. You can learn a lot more from our website. We have a very extensive blog, and we also have a lot of case studies on there. So with that, let me go over the agenda real quick and do some housekeeping items, and then we'll dive right in. So the agenda for today is Damian and I will spend about 20 or 25 minutes discussing ARC's data journey, especially as it related to creating the business case, implementing the doing the lessons learned, as well as what it took to stand it all up. And then after that, we will spend about 40 minutes addressing the questions from the audience. Because the purpose of this particular set of webinars is not to make it a one-way discussion, but make it a two-way conversation, so that we can address a lot of the questions that the audience may have related to, to this, what does it take to do, what is a modern data platform, what does it take to stand up a modern data platform, how do you manage and maintain it? Because there are lots and lots of complications and lots of technologies and processes and people related to the pop up. So we do that. If you don't mind, kindly post your questions in the chat window, and one of our associates will be scanning the chat for questions, and they'll be asking the questions to myself, so that I can then post them to David. So with that, I am going to stop sharing and then turn it over to Damian. Damian, if you don't mind introducing yourself, and then we'll dive into the Q&A.
Okay, thank you, Jay. Hey, Jay, just a point, your audio is fading. It was very difficult to hear you. So you might want to adjust that. There you go,
sure,
much better.
Sure. This is better. Okay. Perfect.
Yeah. Good morning, everyone, and good morning, Jay. Thanks so much for the opportunity to share our journey. I'm Damian Danowski, and I'm the Managing Director of Data Services at ARC, or the Airlines Reporting Corporation. ARC's a travel industry service provider. We settle U.S. point-of-sale airline ticket transactions and provide data products to the travel industry. All right, Jay, would you like me to start sharing, or do you want to ask some questions first?
Yes, please.
Okay.
No, I think if you can share, do you have a slide on ARC by any chance, Damian?
I can't have an ARC slide if you like. Yeah, sure. Hang on.
I think that would be
sure.
good, so that you could, before we dive into the journey.
Yeah. Let's do that. Let me share this with you. See how that goes. And hopefully you can see this document.
Yeah.
Can you see the slide? Let me put it into presentation mode for you.
Yeah, and then we see another Word document on the left.
Oh, you do? Okay, I'll get rid of that. Yeah, that one you don't need to see that. Only I need to see that.
There you go.
There you go. Slides. Okay, let's look at the slides.
Okay,
So,
cool.
who is ARC? How's that? Good. So ARC is, as I said, we're in the business of settling airline transaction tickets. So very simply, when you go out and buy a ticket through, let's say, Expedia or any of the other agencies, or for corporate travel through your corporate travel agent, those ticket sales, that data comes to ARC on a daily basis, and ARC processes those transactions and settles them. So if you think about this pre-COVID, in 2019, we settled over $97 billion worth of transactions. And that were exchanges between essentially about 230 airlines and more than 11,000 travel agencies. So that's a little bit about ARC.
Okay,
all right, Jay,
so
let's dive in.
Yeah, let's dive in. So the first question I have for you, Damian, is why did ARC decide to transform its data platform? What were the drivers, and sort of how did you put that business case together?
Right. Well, so in a sense, we had it a little bit easier than most people, specifically working on the data side, because our data transformation was part of our broader transformation. About 3 years ago, ARC as a corporation undertook to transform its whole way of doing business, its organization, as well as its technology. So our data transformation was a big part of that. And one of the keys to that, which I think is similar regardless of whether we're talking about data or not, is this idea that we were moving from sort of legacy monolithic platforms into the cloud, right? And so we wanted a way to have a platform that was more flexible and more agile, so that we could deliver faster and more effectively for our customers.
Got it. So can you describe the legacy, your legacy platform or the technologies there, Damian, so that the audience has some idea?
Yeah. So we have a data center. Our data center's in Louisville, Kentucky. It has a mainframe in it. It has some traditional, large databases like Oracle, and our data warehouse was a large Teradata installation.
Okay, great. So given your challenges, right, with your traditional data platform and technologies, how did you who championed this cause for creating a new and modern data platform, and then how did you build that business case for it?
Right. Well, I think that one of the issues that we had when, again, as I mentioned earlier, that we have this sort of, when you think about monolithic legacy systems, and obviously these systems are very powerful. So they can process a lot of data, and they're they can provide a terrific service, but the challenge is it's very slow to scale them. So when you think about the legacy data platform, you have a system that on any given day has a fixed amount of storage and a fixed amount of compute resources. And in our case, we had a tremendous amount of competition for that relatively fixed resource. The other side of that coin, another aspect of these large legacy systems is yes, that they're slow to scale, but that administrative overhead, right? In other words, now I have this contentious resource, and I have a lot of people demanding time on that resource, so I have to schedule that limited storage space or that limited compute very effectively. And if I don't, I might actually interrupt our business process if, for example, the wrong query comes in at the wrong time, and I could disrupt delivery of the data. So I had a platform that was sort of became the central port of contention in our overall data processing system. And then again, something that I had to spend a great deal of time managing, or we had jobs running, so you had thousands of jobs, and then you have hundreds of users also competing independently for that resource, and scheduling and balancing all of that required a number of DBAs and a whole lot of scheduling, essentially. So that's some of the really big challenges that you have with those systems.
Got it. So operations, scalability, being able to support the dynamic needs of your business community. Those are some of the challenges that you had to overcome.
Yeah, and I think the other part of that too, when you think about it, is also cost. Clearly, all of that I described is costly, but then again, the implication of this monolithic system is that I have to do what? I have to scale it for the worst case performance, right?
Yeah.
So now I've got to overinvest or over provision to provide that service, because I have to look across the time period and say, okay, on any given day or a given cycle, I might be doing 50% more work one day out of the week, let's just say. And so now I have to provision to that, right? And so, but then the rest of the time, maybe I have some leftover resources. So this idea of fixed resources and having to over provision or provision for the worst case is expensive.
Yeah, good point. So that's a great segue. Let's just dive into we talk about the modern data platform. I think the attendees probably want to know what do we mean, right? What's our definition, or what's your definition of a modern data data platform? What are the components of a modern data platform? So why don't we do that, and then we can dive into sort of the implementation aspects and some of the lessons learned, et cetera.
Yeah, that's terrific, Jay. I like that. Let me throw this slide up here, because I think it's what I'd like to talk about. And what I'm showing here is really this idea that there's a separation now in a modern data platform of the storage and compute resources, right? So I'll talk a little bit about AWS, our provider, and why we chose them, but they have a platform called S3, which is their simple storage service, which is a very highly reliable data store. So when you think about having a data store that's very highly reliable and very scalable, so for me as an individual organization, I don't worry about how much disk space I have left. I don't have to worry about budgeting for that or going out and buying additional resources. I can effectively, within reason, I can effectively continue to add data to that, continuously. So now I have this very reliable. I'm sorry.
Yeah. I said it gives you a lot of elasticity in, with the dynamic nature of the
Exactly. So now if I say I have a very reliable and very scalable dynamic data store, and of course with S3, Amazon talks about 11 nines of reliability, right? So when you think about what does that really mean, and they tout that you might lose an object once in 10,000 years. Okay, and all of their objects, all of their data is stored in multiple locations and sharded out all behind the scenes. You don't need to worry about that. You just realize that your data is going to be there, right? So that's an important thing. So now one big part of the equation is I have this very reliable storage part, and I can separate my computing from that. So in the cloud now, instead of everybody competing for that, whatever computing bandwidth I have on my, legacy or monolithic system, I now can provision individual instances to compute in the cloud. So I could distribute that computation over many users. And in fact, with our solution with Snowflake, who is more or less so we think of S3 as our data lake, and we think of Snowflake as our data warehouse. Snowflake has a query on demand capability. So I'm storing data in what they refer to as data marts or databases in Snowflake. And then they have a very powerful concept called virtual data warehouses. And that's really the computing part of the data. So if you kick off a query, Jay, and I kick off a query, those are operating in independent virtual warehouses. So again, my computing resources scale with my demand. So the two key things here again are separating that storage and compute part, and also providing both of those platforms from a scalability perspective. So I don't have all that competition. And then I'm going to couple that, when we talked a little bit about the legacy platform earlier, we talked about both everybody competing for that resource, and we talked about having to over provision that resource, right? Here in this new platform, it is a pay as you go or a pay on demand type of model, right? So I'm essentially, when I spin up a virtual data warehouse and do a computation, it spins up, it computes, and it goes away. I only pay for the computations that I use when I need that computation, right? So now I have scalable on-demand computation and storage. And from a cost perspective, it's much more efficient, not only in those simple terms, but also now in those administrative terms, because I don't have a team of DBAs worrying about scheduling or worrying about, is the archive process going to compete with some other critical data process? We're past all of that now. So it's a much more flexible, scalable environment.
Got it. So basically the essential components here are the storage and the compute. You basically decouple those. You've also got the ability to provision data and compute on demand, and so that you can support the end user community. And then you also have the ability to manage all of that on an as needed basis. So your cost, component drops drastically because you're not provisioning all of that permanently.
Yes. Right. So I don't have the data center. I don't have the footprint. Let's just put it this way. Our costs have gone down to roughly, from a compute standpoint, and just so for managing that legacy monolithic hardware asset and everything around it, our costs have gone down to about 25% of what they were before, just in terms of the cost it takes me to deliver a given data product, be that a visualization or a report or some chunk of data to a customer, and that's tremendous. I mean, it's huge.
Yeah. All right, so let's just now go into the next topic, which I wanted to cover. So you kind of described the platform, you described the components of the modern data platform. What did that journey look like? Going from your traditional sort of monolithic systems to a modern data platform in the cloud. Can you spend a couple of minutes sort of describing that?
Sure. The journey, when you talk about transformation, it's not a one-dimensional problem, right? You have, you can talk about the technology all day long, and that quite frankly is the easy part, right? It's really all about the people and how you manage that. So for example, in our case, we had a wonderful staff, and that we do have a wonderful staff of people, and they had a lot of skills in what I would say were the legacy ETL processes, like the very large ETL tools, the 4D tools and all that stuff. But now when you go to the cloud, you still need to do similar things, but you need to do them in a different way. So we had some retraining there. And we went through a number of fits and starts with that. And so we originally tried to purchase a, more of a traditional ETL type tool that was available in the cloud, thinking that it would be easy for our folks to move over to that. And we had some struggles with that. And then our implementation partner said, hey guys, you've got all these folks over here, and one thing that they do know is SQL. We have a lot of people on our staff that are very, very good at SQL. And you've got this resource here with Snowflake that I can effectively do query on demand. Okay, so today our ETL processes are actually realized by some Python scripts and SQL that we're able to use. So Snowflake is not only our data warehouse for delivering our data and providing the analytics that we're interested in, but we actually use that as our ETL engine. So it's able to read data from the data lake, transform it, and write it back to the data lake very efficiently. And so, that was a big step for us. So one, think about it this way. We save a bunch of money on licensing of tools and having to retrain people on a new tool. And then we turned around and we say, well, let's leverage what our folks already know. And we're able to realize that using the platform that we chose.
Got it. So how long was this process? Like if you were to break down between the due diligence and the discovery work up front to the actual design and architecture, followed by the implementation? Okay. Like what are we looking at?
Right. So where we are in our journey is the overall ARC's transformation programs. We're about 3 years into it, and we're in about 2.5 years into this, what we refer to as the data transformation. So we've moved almost all of our data from our legacy platform into the cloud. And then we're moving, if you will, our data products functionality so that they're getting to the point where they're sourcing all of their data from our data lake and realizing it through Snowflake and delivering it to our customers. So probably by the end of the year, so maybe like a 3-year journey, we'll have all of our data products sourcing data from the data lake, and they'll be sort of fully transformed and in production in our new environment. So like I said, that journey takes a good deal of time because, you know, we did have the sort of challenge trying to go one way with the ETL tool, but I think we did the same sort of thing with AWS. And what I would say, it doesn't matter whether it's AWS or Azure or Google Cloud or whatever provider you choose. One of the big hurdles to overcome in a transformation like this, a transformation to the cloud, is in a sense, to be very simple about it, you have to trust the cloud. Right, a lot of people are very concerned about this technology and are very concerned about making that leap, and they often want to do things the same way that they currently do, maybe in their legacy data center or however processes that they use, and they're not taking advantage of some of the things that the cloud provides. A very, very simple one, again, it's AWS based, but the other providers have this, is the concept of Lambda functions. Right, so the ability to provide an event-driven architecture. So for us, with our data lake, you know, a file drops into a bucket on AWS, and that triggers a Lambda function that triggers the entire data processing flow for that particular data item, and then it ends up in what we call the process zone of our data lake, and it's therefore available for our data products teams to consume. So that whole process, again, completely event-driven, completely hands-off. There's no scheduling, and that's a very powerful tool. But if you start out and you start out thinking in the ways of, okay, I need a scheduler, I have to run this job, it doesn't really work that way in the cloud. So you have to sort of let go of a lot of that stuff. Is that helpful to the question? Answering your question? Okay.
Yeah, that was helpful. So now we are already at 26 minutes past. So let's take a couple of the remaining questions, and then we'll, you know, the ones that I have, and then we'll dive into the ones that are coming in from the audience.
Okay.
So the next question that I would ask, maybe a couple of questions. One was, what were some of the challenges and bottlenecks that you ran into, and then what were some of the lessons learned? You did mention the ETL tool as one of the, you know, and the upskilling of your resources. Could you dive into some of the challenges as well as some of the lessons learned?
Yeah, sure. I think that, again, like I just talked about with regard to the sort of, and I use this phrase loosely, you know, sort of trusting the cloud is taking advantage of the technologies that are there. But you often run into the idea that let's do lift and shift. Let's just get into the cloud, get out of our data center, cut that cost, and move in that direction. And a lot of organizations try that, and it's very difficult because, let's face it, most organizations say, or a great many organizations already have a virtualized platform in their data center or with their provider. So it should be relatively easy to move those things to the cloud, and often it is. But in talking to other folks who have done that, and our experience, a small part of our experience with that has been that you don't really get the efficiencies, and you're just sort of trading one data center for another. But again, if you go back and think of the cloud as not as a data center, but literally a set of computing resources and computing tools, once you start to use and take advantage of those tools, then you really get the benefits of it, because then your model becomes more of, like I said, event-driven, more pay-as-you-go, and that's when you really start to see both the efficiencies from from an agile perspective, from the ability to deliver to your customers, and also to help you reduce and manage your costs. So I think that's an important aspect of this, is looking at this saying, yeah, I could just lift and shift, but what does that really get me, right?
Yeah. Good point. So in terms of, again, we don't want to, we are tool and technology agnostic, right? So the only reason for sharing AWS and Snowflake is because that's what Arc used.
Right.
So just for the clarity to the audience, I think there are many different permutations and combinations of the architecture that could be created that would best suit your requirements. But one question for you, Damian, before we jump into the questions from the audience, is what was the due diligence process that you guys did, to pick these particular technologies or tools, etc.? What was the thought process there? Because I'm sure the folks in the audience are wondering, right? Because there are lots and lots of tools out there, lots of technologies, especially in the cloud as well as on-prem. So just if you could share your thoughts, that would be great.
Sure. Yeah, that's a great question, Jay. And to be very honest, that's probably actually one of the more difficult parts of this process. When you think about a transformation project or program on any scale, just like with many other things that are, you're trying to really make a big difference to your organization, and sometimes getting started can be the most challenging part. We had developed what we called a technology council, which was a group of maybe, depending on the function, up to around 10 folks. And it was a combination of technology leaders and architects. And we brought in some outside folks to help us, bounce ideas off and things. But we went through a series of POCs by sort of functional area. For example, we realized we needed certain things on the front end. We realized we needed this idea of where are we going to store all this data? How are we going to transform and deliver the data? So we sort of broke our legacy system down functionally, and then went through each piece and said, okay, well, who's the right vendor to go with this? And so, for example, when you think about data warehouses in the cloud, you just mentioned there's a lot of possibilities out there today. We were sort of fortunate that we did a very large POC with Amazon Redshift, and there was a lot of really good features there. But at the time, that platform really wasn't going to give us what we wanted from a flexibility and a scalability perspective. And at that same time, along came someone had heard about Snowflake, and we started digging into their platform and realized, hey, this query on demand capability and the ability to spin up, if you will, a cluster of these virtual data warehouses means we can, compute and solve our problems at our time, how we decide to invest our time and energy in doing that. And so there was, a lot of those factors weighed into how we made those choices. And so I think that, what I would say to folks is that having a solid tech team and having some consultants to sort of check your work, if you will, right? Look over your shoulder and say, guys, in other words, having an outside objective feedback is very important, because organizations can become myopic around some of these things, right? So someone to look over your shoulder and say, do you really think that's the way to go? Is very important in that early stage, so that you can sort of, if you will, get out of your own way and make progress.
Got it. Okay. No, that's great. Any other slides you want to share, Damian, before we jump into the questions from the audience?
No, let's just jump right in, because I want to make sure there's enough time.
Yes. So we have about 28 minutes left, so I think we can cover all or most of these. So the first question that came in is, why Snowflake for the data warehouse and S3 for data lake, and not vice versa?
Oh, I like that question. I like it a lot. So Snowflake does have the ability, and they advertise a feature to build a data lake. And so when you look at the architecture that's on the screen in front of you, there is some duplication there, right? Because under the covers in Snowflake, they're storing all of your data in S3 as well when you're on Amazon. And so in a sense, we have redundant storage. And so why have those two separated? For us, when we started out our journey, one of the things that we wanted to do initially was try to be as platform agnostic as we could. And so it's a fair critique to say, well, you're on AWS, you chose that platform. And yes, we did. And we're pretty far down the road with that in terms of being embedded into that platform. But we wanted to try to be as flexible as we could with all of our other tools so that as technologies come and go, it's easy to adapt. So what I would say to you today is that with all of our data in our data lake, we talk about our data lake as if it's the single source of truth for ARC's reporting and analytics data. So the way our data processing works, and very specifically, the arrows pointing from left to right. So data files come in, they get processed in the lake, and then they get pulled into data marts in Snowflake and computed on with virtual data warehouses in Snowflake. So this left to right data flow, this arrow on the right here is actually misleading. Data never goes back to the data lake from Snowflake, except as part of this ETL process. And what I mean by that is simply that if you have this separation, I could eliminate Snowflake or any other, technology to the right of the data lake, and I would still have that single source of truth for ARC's data. So if I wanted to deliver data through another mechanism or directly out of a bucket in S3, I could do that. And so this was a way early on for us to try to adhere to some level of separation and not completely become dependent on any one given vendor. And if you looked at a broader picture of our architecture, you would see that decision in a number of other areas. Now, have those lines gotten blurred? Yeah, a little, but we tried to adhere to that at the beginning. And from a cost perspective, given that S3 is relatively cost efficient in terms of storage, and Snowflake is as well, we're not feeling a lot of pressure with regard to having both, paying for storage twice, if you will, for parts of our data. And that's another good point of it too. It is only for part of the data, right? So I hope that answered the user's question. I'm sorry?
Yeah. And the lake in this case is storing historical data, right? And it's governed and highly controlled.
Right. Yeah, that's the other thing. And so Jay, I'm glad you and I are having another session next week to talk about this, because when you say, okay, great, I have this very scalable, this lake I can store all this stuff in, your next question is, okay, well, how do I make sure I can find everything? And how do I know exactly what it is and what I have, right? So you need a data governance program, and you need some tools to help you with that, because it can quickly scale out of control, right? And so next week we're going to talk about that, and I'm excited for that conversation, because you and AlyData helped us so much get that data governance part of our capability started and running effectively. And so we've got some good stories around that part. Does that help?
Yep, that helps. So the next question that came in, Damian, is, are there applications running off of Snowflake? And are they applications that are transactional in nature, meaning feeding or getting data from external websites, for example, and storing those and manipulating those?
Oh, okay. No, another good question. And the short answer is no. We made the decision pretty early on that everything that was any data items or data sets that were needed for our reporting and analytics products needed to come through the data lake and be managed by the data lake. So again, Snowflake is, as our data warehouse, sort of reading from the lake, grabbing those artifacts, if you will, and doing computations on them, and then delivering them either directly to a customer as a data set or as a report, or they're delivering that data, say, to Tableau so that a visualization can be created from it. But in terms of separate data coming into Snowflake and being stored there that is not in the data lake, that's not happening. And that's one of the things we'll talk a lot about next week, Jay, with regard to governance, because you have to make some pretty hard decisions there so that your data stays organized, right?
Yeah.
And so having that sort of single source of truth in the lake is important to us, specifically around that process. Because if I had folks, just dumping data or grabbing data sets and using them in Snowflake, they certainly could do that, and certainly locally efficient, if you will, but then it quickly becomes a problem in terms of managing that data and keeping your arms around it or governing it at the very least.
Yeah. And then privacy is another big area these days, right? Privacy and access control. So making sure that, all of that sensitive data that's coming in gets cataloged, it gets tagged, and it's appropriately managed becomes very critical. So having the data lake as your authoritative source, is a good way to go, because then you can control and manage everything there, and then push things out from there in a controlled manner.
Yes, that's exactly right. And that, well, again, hopefully we'll talk about that in great detail next week. But that's another big reason to do that is that governance and control aspect. Absolutely.
Yeah. The next question that came in is, what will happen to the Teradata data warehouse in your end vision? Is that moving to the cloud, or is it being replaced by this modern data platform that you have?
Yeah, it's being completely replaced by the modern data platform. We will be decommissioning that platform, and so what we've been able to do is find a way to take the data that flows into Teradata and direct it to the lake. So today we make effectively a copy of that because we still need the legacy system for some of our business functions. So we have to keep the data flowing there. But that same data, if you think of it as like daily batches of data for simplicity, that same batch that would go to Teradata for processing on a given day goes to the data lake for processing on a given day. And at some point, hopefully in the near future, we're going to cut that other spigot off. And then once we do that, then our Teradata warehouse goes away, and we'll be completely sourced off the cloud.
Got it. There is a request, Damian, for you to expand the slide if you could. Some people are having trouble.
Oh, sure. I'll see what I can do. See if this works. Oh yeah, I definitely.
Does that
help?
There you go. That's much better, I think.
Oh, okay, good.
That's excellent. Okay. Next question that came in was about the Lambda functions that you mentioned, the event-based triggers. So the question is, if the Lambda function triggers the whole process without scheduling, what happens if you have to back out of some issue, if you have to back out of a file or something that happened in the past? How do you handle that? Is there some sort of versioning or some other capability that you've built?
Right. And another great question. So when you shift to event-driven processing and shift to this idea of a data lake, to give you an analogy, if we went back to a traditional database or data warehouse type of process, maybe a database administrator would run a query that would fix up those specific columns or replay a certain amount of data. The problem with that is that you lose the fact that happened. So 6 months, from now, when you're thinking, God, why did that data doesn't seem right? How did it change? It's easy to forget that. You don't have that. We have a data lake concept where we created a data lake that's immutable. And so when I store a bucket, I store a bucket. Now, if I have to replace that bucket and the new bucket becomes, if you will, the reference bucket, that sometimes happens if I have errors in the system. Beyond that, there are occasional data errors and things where I have to correct data. So then I have effectively a change data capture process where I'm writing what I call change files to, if you will, companion files to our source data files in the lake, so that then those can be picked up and processed and affect those changes. So the data lake becomes, if you will, similar to a write-ahead log in a traditional database. It becomes a series of events that are realized in the data, and then you do have to sort of put all that back together or apply those changes and that is all done for us in Snowflake, or when we actually compute with Snowflake. Now, that architecture, there's been lots and lots of papers about that. You can dig into that stuff. It does have limitations if you have highly changing data. So we are fortunate that we process primarily structured data that changes infrequently. So you would read about this type of an architecture or this type of approach, and if you had 1,000 changes or 1,000 of these little companion change files, it becomes very inefficient and quickly overwhelming with this. But for our approach, we were able to take advantage of the fact that, again, we have very, very specific structured data, and it changes relatively infrequently. So applying those changes is reasonably efficient for us. But that is something we're continually working on. And I would say to you that as we get into the next generation of our data lake, if we were to start today with everything we've learned over the last few years and do it again, we might do it a little bit differently. But this was a tremendous and very effective start for us. But of course, like any system, it's not without its limitations.
Yeah, got it. So the next question that came in is, now that you have built this modern data platform, where do you go from here? Like, what's the sort of the roadmap, if you may, in terms of additional capabilities or additional functionality that needs to be built out in this?
Right. So one of the things we pay close attention to is that now that we're able to, a lot more effectively and a lot more flexibly deliver data products to our customers, just like everything else, they now are more demanding. So one of the things that we focus on is efficiency of our data pipelines and availability of our data. So it used to take hours for data to come into our system and then be available for use by the data products team so that it could be realized to a customer. We're driving to get those times under 15 minutes. We want our pipelines to be very efficient and very effective so that we can deliver our data to our customers in a more timely fashion. And that's turning into be a pretty, it's got some challenging aspects to it. And it's a really exciting problem. And there's a lot of work, I think, actually in the field being done on this, which makes it even more exciting, right? So how do I get that timeliness factor to be as soon as possible? And also, our goal is to deliver the data, high quality data in a very timely fashion. And when you couple those two things together, it creates some challenges. So that's what we're working on, is always constantly trying to drive to improve those processes.
Got it. Yeah, great answer. There is a question from Trent regarding tools for data governance, etc. I think, Trent, just for your information, we're going to cover those next week in detail, because that's this particular webinar was the objective was to talk about the platform and the components of the platform, address some of the challenges and best practices. In the webinar next week, next Thursday, 12 noon, same time, we're going to be talking about all of the governance and maintenance and sustainability of the platform. So if you don't mind, please hold for that. Please join us next week, and we'll certainly be diving into that.
Yes, Trent, please join us. It's going to be fun.
The next question that came in is, why not use Redshift instead of Snowflake? Redshift being native AWS could blend in more easily. I think you covered it in the beginning, but I think it'll be good to kind of discuss it some more.
Yeah, it's fair. And I'll have to put my thinking cap on a little bit, because we did these POCs over 2 years ago, and we did dig into Redshift quite a bit. At the time, and so I want to preface this by saying, at the time, the capabilities of Redshift for processing some of our things were very good from a straight ahead performance standpoint. If I just looked at, I'm going to query something on 1 billion rows, and it's very good at that. But there were issues with scalability of that service and some of the clustering issues at that time. And again, I'm sure they probably resolved some of that stuff. And so and I would just say this, and you know, this journey it takes a while to learn the new way of thinking about some of these things. So Redshift is a columnar, you know, data warehouse. It deals with columns of data versus a traditional relational database system, which deals in rows, right? So there's a lot of very powerful things you can do with that. But at the time, that sort of organizing our data in that way was very new to us. And it was something that we weren't thinking about. So it may very well be, to be completely fair, that we weren't able to really take advantage of everything that Redshift had to offer at that time. And then along came Snowflake, and it was just one of those things, like a lot of relationships, it just gelled, right? A lot of people on our team got it. They were able to effectively use the tool. We had a couple of our more senior tech guys who were just able to do kind of magical things with it, and we're also very good at sort of socializing that. And then it was one thing led to another, and it is a terrific platform. The one thing that it does that was really helpful to us is that we store all of our data in Parquet files. So this data lake buckets you see here, you have a raw zone where a data file lands in whatever format it's sourced at. And then it's processed into this process zone, which is basically a series of Parquet files. Now, what's wonderful about Snowflake is it natively just can consume those Parquet files and treats that file as if it were a database. And so you can actually point a query directly to those files, you know, the buckets or folders in your process zone, and run a query. And so it does that very effectively and very simply. And that was one of the powerful tools that enabled us to get started so quickly with it. You couple that with this concept of virtual data warehouse, and it's quite, we thought that the scalability of that aspect of it was better than Redshift. And again, I'll say the words at that time. To be fair.
Got it. No, I mean, yeah, and technology evolves, and your architecture is probably going to evolve over time as you learn more things. And you know, so this is an evolutionary process and a maturity journey.
Yeah. Oh yeah.
And there's never a right answer. There's so many different, depending on your specific situation, you could have multiple answers and multiple solutions to the problem.
Absolutely. Cool. You're right. It is a journey.
The next question that is related is, was Snowflake used for aggregated data layer and business views, and S3 data lake for curated data? So I guess around what is the purpose of the
I guess I'm trying to understand the question a little bit. Could you repeat the question?
Yeah. So it's saying, was Snowflake used for aggregated data and to give a business view, I guess, an abstract view of the data from the lake? And is the S3 data lake for curated, is the data lake for curated data?
Right. So I think if I'm answering the question that you're asking, I would be happy to take this offline and talk about it. But I think the answer is we treat the data lake, if you will, as base data. So we try not to do aggregations. We try not to build data sets that are aggregations in the data lake. So we want the data lake to be raw or basic data that is then pulled into data marts and aggregated in Snowflake. So some of our data marts do have, reasonably long lives in Snowflake for that reason. So we have some computations that happen, or some aggregations that happen and are managed in Snowflake. So we try to avoid, if you will, computing in the lake, so that the lake is really that source of base data. And the reason for that is that I want to have that level of flexibility where, if I need to create an aggregation, or if I need to do something with the data, I can pull it out of the lake and recreate that aggregation anywhere, right? It really doesn't matter. So that was the idea about that. Hopefully that answered the question. But again, if I didn't understand the question, I'd be happy to take it offline.
Sure. Thanks, Damian. And the next question, or a couple of questions that came in, are around the data quality process, right? Because you have your raw zone, then you have your process zone, you have some of the other activities happening within the data lake, and then from there the data is sort of sent downstream to Snowflake. So I think folks want to know, how do you handle quality, and then are you using any kind of tooling, or is it homegrown processes?
Right. So the data lake that we have built is a bespoke data lake, meaning we've built it ourselves. It is all hand coded. For us, that made sense because again, we have a lot of structured data, and we know what data is coming to us. So we have, if you will, hundreds of feeds, but we know what every one of them is. We know their format. We know the frequency that they're going to arrive, whether it's daily, weekly, whatever. So we know what's coming. So we're able to then create our own pipelines for those specific data items. And so as the data moves through the data lake, our idea is that at any given time, if you were to erase everything in Snowflake, you could recreate it and get the same result out to a customer. So if a customer had a report from last week or a visualization somewhere, if I just lost Snowflake for a moment and I had to throw away all the data marts and recompute everything, I should get the same answer tomorrow as I did today. And that's another reason why we chose this sort of architecture that separates these two things and this concept of the single source of truth. So the other side of this question, I think, had to do with how do you manage quality and changes. So using this approach, all of our changes happen in the data lake. So if I have to have a corrections file, if there has to be some manner of data update, talking about data updates in a very generic way, then those updates happen in the lake, and then Snowflake refreshes those views or refreshes those materialized views and pulls that corrected data set back up. There is no right to left, there is only left to right. And that is part of our governance and control process as well, right? So if I am saying to you that if you pull from the data lake today and pull from tomorrow, you should get the same answer. That should hold. The reason why I'm trying to control where changes happen, making them happen, if you will, in one area, in one part, and that part we chose was the lake.
Got it. And so basically, what you're saying is that the data quality is built into sort of the event-based mechanism that you have, and all of the processing that happens as the data is coming in and gets stored in the lake, and then that becomes your system of record or the single source of truth. And that's then everything downstream from there is consuming that data. So hopefully the idea is you're controlling quality at the lake, and to make sure that again, there's immutability as well as high quality and availability being taken care of.
Yes, that's correct. And in fact, in our model, in the model you have on the board here, you could think of Snowflake as just another consumer on the data lake, right? And that's the goal for us, is to make sure that our quality processes and that we're delivering data quality at the data lake interface. And that's our goal.
Yeah. Got it. Okay, so we have about 3 minutes remaining. There's one more question that came in. Maybe we could just address that. And then if there are other questions that come in, please send them in. We will either tackle them next week, next Thursday at the same time at the governance session, or we will send you a response offline.
Sure.
Damian and I can work on that. So the one question that came in is around data retention policies as well as your backup procedures, etc. I'm assuming that's part of the cloud, contract that you have, but it'll be good if you can spend 15 seconds on that.
Right. So we do have specific retention policies on data. we try to keep. In fact, I think we don't have retention policies on our raw zone, which means the raw data that comes into our system. I never want that to expire. I always want to be able to go back if I have to and recreate a downstream data set, right? In the process zone, we do have retention periods because we know, roughly how long we want to keep our data active. And so we have retentions that might shift that data. There's ways with S3 to say after a certain amount of time, then this thing goes off into Glacier and becomes part of less frequently accessed storage. And so we use the tools like that. We don't have, at this time, we don't have a specific, tool set or a heavy management layer there. We use sort of the built-in things that say after a certain time, you go to infrequent access or Glacier. And then for these buckets, like I said, with the raw zone, we don't ever want to move those off of S3 because that's like the core. I always want to be able to start with those files, rerun all the ELT jobs and get to the process zone or be able to recreate the process zone if I had to.
Okay, awesome. Thanks a lot, Damian. That was fantastic. I think we covered a lot of ground, lots of very interesting information that you've shared and your lessons learned. We're right at the top of the hour. So what I want to do is just poll the audience real quick, if you don't mind. We want to offer webinars that are going to be interesting and of value to our audience. So if you could take like 15 seconds to quickly answer this poll, that would be very helpful. So that we can then use the information to develop new webinars and new topics.
Yeah. So Jay, thank you very much for the opportunity. I really enjoyed this. I appreciate it. I hope folks got value out of it. I think we have a great discussion for next week as well. The governance aspect of this is just as exciting as actually the data part. So I think that'll be wonderful.
Yeah. No, thanks a lot, Damian. It's very nice of you to accommodate us and share your thoughts. Again, for the attendees on the webinar, Damian and I are pretty active on LinkedIn. Please feel free to reach out if you have any questions, any follow-ups, and please share the information related to next week's session with your friends and your network, because we're going to be talking about data quality, we're going to be talking about lineage, we're going to be talking about catalogs, we're going to be talking about governance. So I think it's going to be very, very interesting discussion, and lots of good information will come out of that session. So with that, I would like to thank everyone for joining us, and we look forward to seeing you next week. Same time, Thursday, February 18th. David and I will continue our dialogue and discussion, and hopefully you will benefit from that. If you have any feedback, please drop me a note. Any constructive feedback you have, we will want to keep improving these sessions and make sure that we're adding value to you guys. So with that,
thanks everybody. Thank you, Jay.
And thanks a lot. Appreciate it.